Okay, guys. So we have only one type of question in exponent. So I'll just describe what it is and a couple of scenarios where it can be used. So mostly the problems with exponents will come in scenarios like, let's say I say 25 times 35 times 45 times 55 and so on till let's say 105. Okay. And I am saying that this is divisible by 5 to the power s. Find the maximum value of s. So in that particular scenario, you have to think of that, okay, if this is the case, then here I have 5 square coming out. Here I will get 1 5, here I'll get 2 5s, and so on. And there will be a pattern that, okay, for 55 also you'll get a single, 65 also, one only, 75, you will now get again two. So this is the pattern: 2 1 1 1 2, 1 1 1 2, and like that till this particular point. So you can calculate the total number of 5 you can extract out of this expression, and that will be the maximum value of s. Okay, that is one way. Similarly, exponents sometimes are asked that, okay, what is the maximum in this one? Okay, same question. Instead of this expression, you let's say get 1,000 factorial. So how do you calculate this? So there's a particular formula that helps us here, and that basically describes that, okay, what is the maximum or how much of each exponents will actually um, get the power for dividing these numbers in factorials only. Okay, so for that we have a very simple formula. Okay, so what we do is 1,000 divided by 5, okay, plus 1,000 divided by 5 square plus 1,000 divided by 5 cube, and so on till the 5 to the power of x is smaller than 1,000, smaller than or equal to 1,000. And this square bracket is actually the ceiling. So if there is, let's say the result comes 101.2, then you convert it into 101, so nearest integer. Okay, so here what will happen is it basically says that, okay, so this is the power that 5 will get, this is the power that 5 squared or 25 will get, and so on. Okay, so this, all of these are powers of 5, and this comes from 25, and so on. So if the number is huge, it will come with 125 and so on. So this basically adds up that. So in this particular case, you will get 200 plus, from here it's 25, so you'll get 40. Here it's 125, so you should get close to 405, 8, yeah, 8. And the one after that, it might just exceed 125 times 5 is 625, right? So you might get 1 from there, and that's it. So total there are 249 factors of 5 that you can extract from 1,000 factorial. So if instead of this expression we would have 1,000 factorial, the maximum value of s that was feasible would have been 249. Okay, so this is just something you should, if you can actually see why this scenario is true, then it's great. Else this is just one of the type of questions that may come. Okay, if you try to imagine it properly from this example, you should get that, okay, when I'm dividing by 5, I'm getting the numbers which I will get from here. When I'm dividing by 5 square, I'm counting the cases of things like this. That is why I gave this example and this one at the same time, so you understand where does this formula comes from. If not, then again it's a simple formula, so you can remember that particular thing. Okay, if some question comes like this, it's good. Else and there is a good chance of this happening, because this particular thing, like how many factors of 5 you can divide in 1,000 factorial, you'll not be able to do with your computers as well. Okay, so this is something you have to solve by yourself as only. Okay.